Today's episode is brought to you by Musical Surroundings. For over 30 years, Musical Surroundings has distributed high-performance analog playback equipment to vinyl enthusiasts and music lovers throughout the United States. Based in Oakland, California, Musical Surroundings represents world-class brands like Clear Audio, Hanna, DS Audio, and their own line of Musical Surroundings phono preamplifiers. To learn more about the exceptional turntables, cartridges, and analog accessories they offer, visit musicalsurroundings.com. That's musicalsurroundings.com. Today's episode is also brought to you by one of the originals in high-end audio, Purist Audio Designs. Purist Audio Design made the first fluid-shielded audio cable over 35 years ago and still makes them today right here in the U.S. For over 35 years, Purist Audio has connected you to the music. They passionately make high-end, high-crafted audio cables designed specifically to the needs of your system. They list their specs, such as resistance and shield quality, and you can find them at PURISTAUDIODESIGN.com. Purist Audio Designed is veteran-owned and available worldwide. Today's episode is also sponsored by SCHIIT Audio. SCHIIT Audio designs and builds audio components in California and Texas. Based in Valencia and Corpus Christi, their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit SCHIIT.com or stop by their retail store in Old Newhall, just north of Los Angeles. That's SCHIIT.com. Hello, friends, and thank you for joining us. This is the Occasional Podcast, Season 6, Episode 3, A Guide to Tube Amplifiers. And what can be said in this episode can actually be applied to headphone amplifiers as well, but for the majority of it, please come with an understanding that we're talking about tube power amplifiers. So, in place of a solid-state amplifier, which is a very common type of amplifier, power amplifiers and also integrated amplifiers can be tube-based throughout, which is kind of exciting and a little bit more of a rare thing for the audiophile space, but yet it's one of the most beloved because it is like a true analog state of being and one that takes a little more twists and turns to get going properly. We, in this episode, are going to explore all the avenues that we can to help clarify this subject, thanks to the help of our friends Gary Dews of Border Patrol and Mark Schneider of Linear Tube Audio, LTA. But I want to kick you off with a basic understanding of the product category alongside the different type of what we call topologies and categories the tubes fall into. Generally speaking, there are three basic output topologies for tube amps: single-ended, push-pull, and output transformerless, OTL. You're going to find there's a lot of three-letter acronyms that run throughout this entire podcast, but bear with me, they all have their place. There are also different types of tubes, generically speaking. Pentode, triode, and ultralinear are different modes that can be had. Triode happens to be one of the more popular forms in the single-ended triode, SET, formation. Pentode has been used in the past, according to many sources, but has somewhat fallen out of favor in the popular culture with tubes as it is right now. Some amps are actually able to switch between certain modes, so you'll find that some of these different topologies are accessible within the same amplifier. Also important to note is the fact that power can be wanted occasionally with a lot of these, especially as single-ended triodes. So in order to circumvent that, to pair with more types of speakers that are less efficient, an amplifier might be done in what they call a parallel mode, which will essentially allow more than one tube to run in parallel to increase the power. We get into some of the pros and cons of all these types within the two specific interviews that we do. Our first interview with Gary focuses more on SCT and push-pull amplifiers, while our second interview with Mark focuses more on OTL, output transformerless, and specifically with him, another variant called the ZOTL, or Zodal for short. Today's show is also sponsored by Wharfedale. For nearly 90 years, Wharfedale has built loudspeakers for music lovers all over the world. With a warm and natural sound signature, their inherently high-fidelity sonic retrieval simply makes you want to listen to your music for longer. Visit WHARFEDALEUSAdotCOM to discover the high-value Diamond 12 series, the best-selling Linton Heritage, and the no-holds-barred Elysian. That's WHARFEDALEUSA.com. We kick off our guide with a conversation with Gary and yet another term that's often used in tube amplifier design, negative feedback. There is a lot of information to digest, but that's kind of what makes the hobby fun. On with the show, here we go. A guide to tube amplifiers.
Okay, so I briefly mentioned the British company Audio Innovations, for whom I was a dealer. They made a range of integrated and power tube-based amplifiers, some of which used EL34 Pentode type tubes, and some of which used 2A3 triode type tubes. Mm-hmm. I always felt the 2A3-based, the triode-based amplifiers sounded much more real, much more like the sounds I heard in real life than the Pentode tubes was. At that time, I didn't really know much about electronics or amplifier design, but what I did know was that the triode amps, the 2A3-based ones, critically did not use something called negative feedback, whereas the Pentode amps had to. Audio Innovations briefly tried making Pentode amps without feedback, and it was a complete disaster. The things were just vile, and you just couldn't listen to them. So, Pentodes do need negative feedback for very good reasons. They're inherently high-impedance devices. They will produce tons of distortion, and what negative feedback does is it cancels those distortions, it lowers the output impedance, and it widens the bandwidth. Now, this would appear to be, what a great tool. Why don't we just put that in everything? It's only when you realize how negative feedback works that you might start to think, well, maybe that's not such a good idea, because what you're actually doing with negative feedback is you take a large proportion of the output signal from the amplifier, and then you reroute it back to the input of the amplifier out of phase with new incoming signal in order to cancel distortions and the other things that I mentioned. So you're essentially going to hear that information that you already heard again and again and again and again. And I mean, I don't know how many times that same information would be recycled through the amp, but I do know it's a lot. Mm-hmm. Now, engineers will say, oh, you can't hear that, it's so fast. You can't hear it. But the point is you can, because if you listen to an amplifier that doesn't use negative feedback and you compare it to an amplifier that does, the difference is immediate. And it's really, really important. It's a very, very important difference. Leading edge definition on the feedback-free amp is much more precise. The overall timbre of the instruments that are played is much more like the real timbre of the instruments that you hear. The background is quieter. There's no kind of artificial veil or artificial halo that accompanies the sound in the way that a lot of the KT88 type tetrode amps that use feedback do. Mm-hmm. Now, I'm not saying those amps can't sound nice, and I'm not saying that people that like those amps are wrong. I'm just saying that for me, the feedback-free amplifier is the one that sounds the most realistic to me. Now, if we take this a little bit further and you think more about what negative feedback is doing, because you're taking info that's already gone through the amp and you're taking it back to the front of the amp and taking it around, through a gain. What you have is basically a time-based issue. The amplifier is no longer time linear. You're recycling old information over and over again, and in the process of doing that, you mess up, the time base of the amp. With a feedback-free amp, you don't. Signal comes in, signal goes out. That's it. It is a time linear system. I think that is, explains to a large part why your feedback-free amplifier sounds much clearer and less blurred than the amplifier that uses negative feedback. So, in my early days of audio, back as that dealer, it seemed obvious to me that the amps I liked the best were these ones that didn't use negative feedback. And the only amps that can really get away with not using it tend to be triode amps.
Mm-hmm. Okay, so we have triodes. There are single-ended triodes is a commonly used phrase, SET amps. Can you just kind of explain what the other types of amplifiers are, and regardless if you use them or not, like how they kind of well, let me pull my notes real quick. I'm sorry. So what we talked about before. Okay. So what were the two types that you were just referring to? That was a triode.
Yeah. So your typical amplifier output stages. Tube amplifier output stages will be made either from tetrodes, such as a KT88 or a 6550, a KT90 or an EL34, or triodes, such as a 300B or a 2A3, or even an 845 or something like that. You can make single-ended tetrode and you can make push-pull tetrode. You can make single-ended triode and you can make push-pull triode. The vast majority of tube amp manufacturers tend to make push-pull tetrode because they're the amps that it's easiest to get the most power out of for the least amount of money.
Mm. And so of all these single-ended triodes, push-pull, OTL, which ones do you prefer to work with? Because you actually use a couple different topologies in the products that you make.
Yeah, I do. Again, the critical point about all the amps I make is they don't use negative feedback. Okay. So whether you buy the single-ended one, the push-pull one, or the parallel single-ended one, it's completely free of negative feedback. That, for me, is the key point. Mm-hmm. So you would listen to, each of those or any of those three Border Patrol amplifiers, you would hear a characteristic quality to the sound of all of them, which is the fact that they don't use the negative feedback. And so compared to any of the tetrode-type amps that you would hear, the sound is more precise, it's clearer, it has much more precise leading edge definition, no false halos. It is exactly a very, very realistic sound. Now, whether you decided to go for the single-ended, the parallel single-ended, or the push-pull, depends on a number of things. A single-ended 300B amplifier has somewhere between 7 and 10 watts per channel output power. So, this limits to the type of loudspeakers that you can use with it, and it's going to limit how loud that type of amp can go. But if you choose, say, a sensitive loudspeaker, 94, 95 dB, in a reasonable sized room with an 8 to 10 watt 300B amp, you're going to get good sound levels from that. And what you're going to hear is a very, very smooth, very clean, very rich, and I would also say, slightly romantic sound. There is an element that goes with single-ended operation that does tend to add a little bit of romance to the sound. A bit more euphony, if you like. If you contrasted the sound of that one with the push-pull amp, the push-pull amp would use two 300Bs, probably going to give you 20 watts per channel. You can drive a much wider range of loudspeakers. And it also has a slightly different sound because the distortion spectrum of the output stage is different. So in the single-ended amp, you have primarily even order distortion, second, fourth, etc., etc. In the push-pull amp, you're going to have odd order, which is going to be third. And those harmonic distortions, when added to the signal, do change the overall sound of the amp.
Mm. And yeah, we've talked about the order harmonics having different influence, and I think there's not a right or wrong answer, but a lot of people have said there's a preference, though. Some people prefer even, and some people are drawn to odd as well. So would you agree with that it's kind of a preference thing, or do you think that most people go with even?
I think it's a preference.
It is definitely.
And I say that because I tend to sell equal numbers of push-pull and single-ended amps, which might surprise some people. Yeah, some people, they'll come to my place, they'll hear the single-ended, or they might even buy the single-ended off me, use it for a few years, and then say, you know what, I'm curious about, and then they end up buying a push-pull. Mm. And sometimes it goes the other way. You know, they buy the push-pull and then they trade that back for the parallel single-ended. So it can go either way. It is a personal preference. Not only does the push-pull amp have a different distortion spectrum and more power, it also has more impact in the bass, it has more grip, and it has a bit more control. Push-pull amps don't stress their power supplies as much as single-ended amps do. So they can often be a bit more dynamic than your typical single-ended.
And do you have any, from your experience, ways to describe the difference between this first order and or even order and odd order harmonics? Do you think that either has a particular tangible sound?
So your even order harmonics typically sound sweet, typically kind of a little bit soft. You would probably say euphonic. You would say, maybe even say it adds a slight veil, though I don't think that's really a sound. It's more of a texture than a veil. The push-pull with the odd order harmonics is a bit sharper. So the amplifier can sound a bit more incisive in some ways, whereas the single-ended is just going to sound smoother and sweeter.
In your description, the single-ended triout is not a single-ended amplifier. This is just part of the topology. Is that correct? You can have a balanced input to the amplifier.
You can have a balanced input, but that would very quickly be made into a single-ended circuit. Right. So you could have a balanced input that would use a transformer, but the secondary of that transformer would be single-ended because the amplifier is a single-ended amplifier. If you make it balanced all the way through, it's no longer a single-ended amplifier. In a push-pull amp, at some point in the amplifier, you split the signal into two equal and opposite phases. One pushes, one pulls. That's where the name comes from. The signal will run through one phase, it runs through the opposite phase, and it's reunited in the output transformer before it's sent to the loudspeaker. In the single-ended amplifier, the signal is never split up and it's never put back together. It just goes through the whole amplifier in one piece.
So you obviously, there's a lot of people out there that love tube rolling. They find it to be a fun part of the tinkering aspect of the hobby. Where do you kind of lie with that? And do you have a favorite tube aside from the topology that you like to operate with, or do you feel like a specific tube type lends itself outside of the topology that we've described?
I work mostly with 300Bs. I think they sound good. There's lots of different brands available. The reason I really like the 300B is you can get good power out of it without needing a ridiculous power supply. 400 volts and you've got 10 watts. You know, an 845, which is a bigger triode, you need to start talking thousands of, 1,000 volts to get sensible power out of that. A 2A3, you're only going to get 3.5 watts from a 2A3. So the 300B is great because it gives you good power without needing a totally ridiculous power supply, and it happens to sound great in the process. There's lots of different types of 300Bs available. Each of them has a slightly different sound to the others. So yeah, there's a tube rolling aspect that people really like. Has a lot of things going for it. Oh, and to answer your question, actually, it lends itself equally to single-ended push-pull or parallel single-ended applications. It's not particularly better in either one of those.
So it happens to be a quite versatile tube out of the lot.
It is, yeah.
Some amplifiers are powerful and they have only a single tube sticking out the top. Some have two. A couple of Audio the Research have many, many tubes sticking out of them. First, I'd like to say, is there a relationship between the number of tubes and the power? And if you can only get X amount of watts, is it possible just to keep adding tubes to add more power?
Okay. If you look at the specs on a 300B, you will read that it has a maximum plate dissipation of 40 watts. Now, that tells you that's the product of the voltage you put across it and the current you put through it. If you then decide you want to operate that single-ended, that's going to be a Class A, what's known as a Class A topology. And Class A, at maximum, is 25% efficient. So the most you're going to get out of that is 10 watts. Nobody runs a 300B at the maximum 40 watts because they're expensive and they want them to last. So typically they run them at 28 to 32. So you're going to get an 8-watt amplifier, 7 to 8 watts in Class A. Now, if you then add another 300B and put it in a push-pull circuit to make a push-pull Class A, then you're going to get double that power, or maybe a little bit more. Similarly, if you put two together in parallel to make a parallel single-ended circuit, you're going to get the same as well. You could, in theory, put 3, 4, 5, 6 in parallel. But by that point, your output transformer would be absolutely ginormous because it would have a huge amount of current to sync, and you're starting to get impractical. What you also notice from the sound quality point of view is the more tubes you put in parallel, the less focused the sound becomes. There's an element of defocusing that appears when the tubes have to share current. So the single 300B tube usually has the best resolution because it's not sharing with anything else. And then, the more 300Bs you couple in parallel to it, the less the resolution becomes as precise and as focused.
I think this question comes up a lot. When they talk about watts in the tech specs sheets, and a lot of, I think a lot of weight is placed on the specs that people publish in terms of power for their amplifier. People look at that, and it seems wildly inaccurate to what you actually get out, especially when it comes to solid-state and tube technologies. What is the main disconnect there when I have a 400-watt mono that seems to put out less actual volume than a 12-watt tube amplifier?
There's an element of reading the small print when you read the power output. So you need to make sure the power output is quoted as RMS rather than peak, because the peak number is always going to be much bigger than the RMS. You need to look at the small print to see how many % distortion they're quoting at that power output. And then there's an element, I think, of power delivery. Some amplifiers, although they have got a lot of power when measured on a bench, for whatever reason can't seem to get that into the loudspeaker. Other amplifiers, and tube amplifiers are particularly good at this. They don't seem to have a lot of power when you measure it on the bench, and yet they go way louder than you think they should do when you couple it to a loudspeaker.
You made some mention of distortion levels, and I think one of the vantage points of tubes is that they generally measure with more distortion.
They do.
Than their solid-state counterparts. How do you think that distortion adds to the sound, and is lower distortion always better?
Well, we touched on this earlier. If you've got a lot of second harmonic, it's going to lighten the sound, give you, a little bit of extra sweetness, etc., etc. My argument always becomes: are the tools and other things that you need to do to reduce the distortion worse for the sound than just living with the distortion? So if you take a single 300B amplifier and you run it up to maximum power and you see 5% distortion, one way to get rid of that, obviously, is to put negative feedback into the amplifier, like we talked about earlier. That would get the distortion down to incredibly low levels, and the more feedback you added, provided it didn't go unstable, the lower the distortion would come. To me, it's like throwing the baby out with the bathwater. You've lost the reason why you wanted to use that amp in the first place. I would argue that the effect of the feedback, the screwing up of the time base, like we talked about earlier, is way worse than some second harmonic signature on the output signal. I just couldn't see the point of doing that.
Is there any other type of subject matter on this that you think would be very helpful for the listeners to know about in terms of evaluating tube amplifiers?
I think, the question of loudspeakers obviously is very important, because if you're going to use a tube amp, you have to choose a loudspeaker that is tube friendly. There's no point going out and finding a used pair of Magnaplanners and thinking you can connect it to your 300B set and you're going to be in audio nirvana. Mm-hmm. You need to make sure that the loudspeaker is sensitive. You need to make sure it has a relatively high impedance. And if you satisfy those two criteria, then you're going to have a good sounding audio system if you buy a good tube amp to use with it. I think that there's a huge difference between the more common types of tube circuits, like the push-pull tetrode with the negative feedback, the KT88 type circuits, and the triode type circuits which don't use the feedback. That's a night and day difference. They're both tube amplifiers, but they're just not even similar when you listen to them side by side. I personally think the no feedback triode approach is the most faithful. Regardless of measured distortion, which is obviously going to be high because the feedback is not there to cancel it. to me, the sounds that I associate with those amplifiers are so much more like the real sounds I hear from acoustic instruments and voices and things. That's the best approach for me. That's the one I can sit down with and relax with and listen with and really enjoy the music. Everything other type of amp to me just sounds like a sort of synthetic facsimile of it. It's just not quite telling it how it is.
One of the drawbacks I think the general audiophile community might say is for a tube technology is that the bass can get somewhat woolly or mushy or whatever. It can be less tight than a solid state. From my experience, there are solid state amplifiers that can sound very tube-like or euphonic as we've described, and there's some tube technology that can sound very solid state. What do you think is the defining factor in the quality of the bass, and is it possible to get comparable bass quality from a tube amplifier in the low end section as you can? Obviously, it might not be as easy if this is true, but that compared to a solid state.
Tubes are inherently high impedance devices, which means they can't supply current as easily as solid state devices can. Your solid state amplifier should always have an advantage in that area. You can address some of that with negative feedback, which we talked about earlier. You know, if you have a very high power KT88 amp that operates with a lot of negative feedback, you're probably going to have pretty tight bass because it's got the power and it's had the impedance lowered down. With a single-ended triode amp or, like in the Border Patrol amps, I try to address that as much as possible by using ridiculous power supplies, by which I mean they're massively over-engineered. They use choke input filtering, so they have very, very good voltage regulation. And I find that helps enormously to keep the bass tight and tactile. I'm not going to say that it does it as well as a Krell or a 500-watt solid-state amp, but it does mean that the bass is tight and it's punctual, and you can easily know which bass instrument is being played.
Mm-hmm. I love punctual, by the way. It's good. It's so good. Punctual. Are you on time, bass? Damn you. Oh, shit. Anything else you want to add?
Well, I think I'd just like to, round off by emphasizing again this idea that time-based distortion, whether that's in an amplifier that uses negative feedback or whether that's in a D to A converter that uses upsampling, that is more egregious than an amplifier without negative feedback that might have slightly higher measured distortion levels, or a DAC again, which is going to have some measured distortion levels because they didn't upsample. Mm-hmm. It's, to me, all my audio experience, and I've been doing this since 1989, tells me that products that don't mess with the time base sound more real, more lifelike, and more enjoyable to listen to than products that do.
Are there any typical audiophile arguments that you see online or in the forums, this type of thing, that you'd like to address that you think are particularly distracting from what's the enjoyment of listening to music? About tube amplifier technologies? Well,
some of the ones you mentioned, most people think that all tube amplifiers have got soft, spongy bass, that all SETs are useless at playing anything other than very simple music, maybe a voice and a guitar. Anybody that takes the time to come to an audio show and checks out the Border Patrol room will very quickly hear that Border Patrol amps can play all kinds of music. We can play dense, complex music as well as the simple stuff. There are a few commonly held misconceptions, I think, that, like I said, if you do get to an audio show, you can probably find amps that dispel that quite quickly.
Mm-hmm. Yeah, and I think a lot of times those things originate at very low price points where you can't designate. A lot of the misconceptions or the collective observations that people will make, the statements they make about specific technologies, are often restricted to their experiences at very,
right.
Someone with a really tight budget. It's the same thing kind of existed for a while in terms of DACs. There was quite a groundswell of people who thought Delta Sigma could never sound good as multi-bit, and I think if you put enough R&D against any one thing, and it's not just that, it's the quality of the parts that you can afford at higher price points, you can see that a lot can be done with whatever the creator kind of selects along the way. And heard amazing Delta Sigma, and I've heard amazing multi-bit, ring deck, all these things on the digital side. But I think that also extends to the tube side.
Absolutely.
And you can do, yeah, go ahead.
If you buy a relatively inexpensive tube amp, then you're typically going to get small output transformers, and you're going to get just enough power supply to make the thing work. Mm-hmm. If you buy a more expensive tube amp, you're going to get a bigger, better designed output transformer and more power supply. If you've got a poor output transformer and not much of a power supply, you will get that typical soggy, overblown, underpowered tube sound that people talk about. So yeah, you're absolutely right. When you look at inexpensive implementations of any topology, the weaknesses of that topology really do come to the fore. The more you can spend on it, then you can address those weaknesses to a better degree, and then you really do hear what the topology is capable of, rather than just what the parts that surround it are capable of. And then that's when you hear the true test of the topology, rather than just the bits that are associated with it.
Would you say that, relatively speaking, then, that it's easier to design a really good solid-state amp than it is to design a really good tube amplifier?
Yeah. Solid state really came along, I think, in the 1960s. I'm no audio historian, but I think that's when it came, and very quickly pretty much replaced tube amps, because solid state gave cheap power at low price. Low price power, which the tube amp never could. The tube amp would always give you, low power at a high price, and the solid state could give you high power at a low price. The market loved it, and it took off, and that's where it went. So yeah, in some degrees, I would say if you are going to design a budget product, solid state would be the way to go. Because unless you can afford good output transformers and a good power supply on your tube amp, it's probably just going to sound okay rather than great.
Cool. Hey, thank you so much for coming on, Gary. Appreciate it.
Hey, thanks, Brian.
So in further exploration on our amplifier topologies, I'd like to introduce Mark Schneider from LTA, Linear Tube Technologies, and he is vastly familiar with a topology called OTL. And Mark, if you could just tell us what OTL stands for and just give us kind of a synopsis on your amps that utilize OTL.
Okay, so OTL is output transformerless, which means there's no output transformer between the tube and the speaker. Of course, you could have another transformer, a power transformer. Typically, most have power transformers, but the two matching transformers are the output transformers. The output transformer job is to couple the speaker, which is very low impedance, to the tube, which is very high impedance, typically. So the classic OTL is the Futterman OTL, which was invented by Joseph Futterman in the 40s. And it involves using 2 to 3 times as many tubes as a regular tube amp. So you might have 12 tubes, 16 tubes per channel. They are run at their full output, because the output is very low in his type of topology. And so you get a lot of heat, the tubes burn out quickly, and they have their output impedance is still around 16 ohms, and so it can't really drive stuff lower than 16 ohms, and some amps can be damaged if you hook up less than 16. And you have to change the tubes a lot, so it's an expensive implementation. But the advantage of OTL is that the transformer introduces artifacts from the iron core, and it saturates over 25 to 1 turns ratio, so you can only use 25 to 1. If you do calculations for what the proper turns ratio between a tube and a speaker, it's typically 50 to 150 to 1. So you can't really match it perfectly, so the transformer doesn't do a very good job. The other thing it does is they add intramodulation distortion, and that appears in your sound as a warmth. So tube amps, compared to solid state, you get this extra warmth, and sometimes the warmth can be almost syrupy, extra warmth, and a lot of people like it, but it covers up the detail. You get no micro details, because that just covers it up, and it's not accurate as the original performance. So having no output transformer, you lose all that. You get a much more natural sound than with it. The other type of OTL is the Zodal, which is zero output transformerless, zero hysteresis output transformerless. It was patented and designed by David Burning in the late 90s. The patents just recently expired. But he has a completely different approach to the OTL. The OTL is actually a byproduct of how he operates the tubes, and his topology is different than any other tube amplifier out there. And what he does is a couple things. One is he operates the tubes at 250 kilohertz. So this is like a radio station. So an AM receiver, you take the audio, which is 20 to 20,000, say the 101.1, it puts it on to the carrier and it rides on the carrier. And so it's still the exact same waveform, it's just at this offset of 250 kilohertz. Your receiver then receives it, strips away the character, is left with the audio. So we do the same thing inside the amplifier. And when we do that, it changes the impedance plane between the speaker and the and the tubes, and you actually don't need an output transformer. So, but there are a lot of other benefits that we get, and so we operate the tubes actually at twice the rated output voltage. So a 350 volt tube, which if you put it at a higher voltage than another amp would be destroyed. We run those actually at 750 volts. We run our EL34s at 1,000 volts, but we use 1/3 the current. That's why they don't explode. So they actually last 3 times as long. They put out 1/3 the heat, and and you get a much wider voltage swing because you're getting almost double the voltage swing. So it tends to be more dynamic and more musical.
So would you say that the OTLs and the ZOTLs that you work with, do they have a particular characteristic that you think people like, or?
They're very open sounding, very transparent. You get all the detail that you get with a solid-state amp. Our ultralinear is a slightly different topology. That's our most detailed, and you can compare it to, say, a Past Labs amp, and you get exactly the same amount of detail as any solid-state amp.
And we had talked briefly earlier about odd and even harmonics. You were saying that these designs utilize an even harmonic, is that correct?
Well, so solid-state amplifiers, when they distort, or when they are driven to their top, they distort using the odd harmonic, and the odd harmonic has a harshness to it, and that's why solid-state amps, if they're distorting, you hear that harshness that nobody likes, or if you're listening to a cheap amp and it's distorting, it's harsh. But the tube, it distorts in the even harmonic, and the even harmonic is the soft distortion, and so you actually, if it's just one little note or something, you can't detect it. It could be 150% even sometimes, and you couldn't detect it. Obviously, if it distorts a lot, you're going to eventually hear it. But so you can have a 15-watt tube amp, and you might get the reality. It's the same as a 25-watt solid-state amp, depending on the musical material.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes PartTimeAudiophile.com, The Occasional Magazine, the PTA Newsletter, and AudioHead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. If you haven't already, please subscribe to the Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.